Okay, and we're COMP123. Welcome back from the break, for me anyway. And it's week 7, lesson 7, part 1. And I want to review a little bit of stuff that we did last week. Talk about assignment number 3, right? Let's look at that assignment really quickly, just to go over some of the details again, because I know that some of you, you're mentioning to me that, hey, I'm a little bit confused. I don't understand what to do. How do I implement this kind of thing? That's what I heard. So let's talk about it because I think it's important for us to understand, like we can all be on the same page here, right? So let's look at the assignment. Now it's called Abstract Planets. If you haven't had a chance to look at it, I'd be very surprised and actually afraid, right, for you guys because it is what it is. By the way, I generated this outline here. I generated it through Visual Studio. So if you guys are interested, you could do the same kind of thing, mapping out your classes and everything else through Visual Studio. I made this with Visual Studio, right? And you can do the same thing for yourselves. There's tools that are built into Visual Studio to create almost like an outline of what your classes look like, right? Okay, so let's take a look at in more detail. So I've got a bunch of fields here. I mean, again, how would if I was going to start off with my abstract class, if I was going to make this thing from scratch, I think my starting point would be here, planet, right? So the way I would start it off is label this. If you notice, abstract it's italicized, right? And the reason why it's like that is because it kind of shows you this is the standard, as an example, that tells you that this is an abstract class. It's italicized, right? And if you notice here on the subclasses, you notice that there's a little arrow that's in here that shows that these are subclasses of planet. See? They also, this little symbol here shows two things. I has moons and I has rings. Those are interfaces that have to be implemented for the classes, or for these two classes here, right? And of course I have my main program down here, which is just going to run everything. That just links everything together, right? This thing down here, right? So again, I mean, I would start off, if I was doing this assignment, and I would kind of plug all these things in here. So the first thing I would do is create a bunch of fields, diameter, mass, blah, 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 whatever, and I would put that in. And then I would create my getters and setters, the properties for some of these fields right here. And here, if you notice, the method, planet, is the actual constructor method right here. This is the constructor method, and it's going to take a name, a diameter, and a mass, right? I'm also going to override the toString method, right? And that's why it's included here as something I'm going to override, right? So these are all the things that I would do. I would kind of map this all out just like this, right? And I would use this as a guide. I mean, if anything, before I read any of this stuff down here, I would start mapping things out according to this diagram, right? Now you should see some kind of diagram like this. You should have seen it already with Professor Narendra. He would have kind of come up with something equivalent to what you've already seen in terms of the class diagram. And this is what this thing is, right? So giant planet and terrestrial planet, these two are other subclasses. And again, you have a kind of a map of what the class would look like. So it has, from a field perspective, it has a type, and the terrestrial planet has a field of oxygen, right? And if you notice, I've kind of put these two subclasses here, this one and this one, I've kind of mapped them out, and they have a few methods. One is the constructor method right here. The first thing you see here, this giant planet, is constructor, and it takes name, diameter, and mass, and type, which is a little bit more than what the superclass takes. You notice the superclass takes name, diameter, and mass. Here, the giant planet also takes type, and the terrestrial planet also takes oxygen, right? Because we have to check to see if these conditions are met. Now, if you notice, I also have methods that are called has moons and has rings. Why? You have to have those things if you're going to implement these two interfaces. Because remember, interfaces, what they do is they make you implement, right, different methods and other things that are inside, that are defined in the interface. Okay, that's all they do. Interfaces basically help you create the shape of your class. Okay, that's all that they do. It's almost like a blueprint for the blueprints. You can't have multiple inheritance, right, in C# and in many more languages out there. That concept still isn't being used, right? What I mean by multiple inheritance is you cannot have a class cannot inherit from two different classes. You can't have, two different superclasses that the class is going to inherit from. However, we have interfaces that can add additional functionality on top of the main superclass that a class would inherit from. So here's an abstract class. Well, Giant Planet is going to inherit from this abstract class. And of course, I would use the extends keyword in order for me to do that. So I would say abstract planet, this is my class, and this Giant Planet would be Giant Planet, this is how I would write the class, extends planet, right? And then implements, I would use the implements keyword to implement my interface. Implements I has moons, comma, I has rings. That's how I would write it. Yes?
That word you said, Giant Planet, you said a word I forgot, and then you said planet. Is that just the
Extends.
colon? Extends. That's
The colon, yeah. So the colon, the keyword in different languages, if it's Java, right? If it's Java, it would be extend. You'd have to use that word. For C#, you use the colon, right? It's the same thing, really, at the end of the day. And then how do I implement interfaces, right? You've got to implement interfaces. Well, the way to do it is add another comma to it. So colon, the superclass, comma, the interface, comma, the other interface, comma, the third interface, comma, the fifth interface. And you can keep adding interfaces that way in a string of interfaces. So that's how you do it. That's the syntax for adding additional interfaces in there with the comma, because you can add as many different ones as possible, right? In other languages, you need to use the implements keyword, right? But it means the same thing. So from a syntax perspective, that's how it would look. Yes?
so the colon is the extends, and to like add more extends or whatnot, it's not another colon. They're separated by comma.
Well, let's rephrase that. You cannot extend more than one class, but you can implement more than one interface, right? So I can extend a class and I can implement interfaces, right? And it's all after the colon. Okay, so the way it would look is, if I was going to go into C# now, let's pull up this example that we used last time, which was this, this crazy, what do we call this? It was an insane deck, kind of card dealing example, right? And people were confused, they're like, I don't understand. But let's take a look at some of these things. I got faces, right? And I got suits. These are just two container classes that all they are is like constants. That's all. So I want to access these things. I also have this deck class, right? So here's my deck class. And if you notice, it doesn't extend anything, but it does. It's a little bit of a bigger class. You guys haven't seen this big. That's why I introduced it to you guys, because it does different things. When I roll this thing, as an example here, I'm going to roll I'm going to get unique elements: 11 of clubs, 9 of clubs, 4 of clubs. Hey, I almost got a straight here, right? Almost, maybe just a flush with the clubs. If I had another club there, I would have a flush right there. It'd be a winning hand, right? But if you notice, if I hit it again and if I run it again, and by the way, I put this up on GitHub for you guys, and I want to talk about this because tomorrow I'm going to use some stuff that I did in this class, right? Hint, hint, for your tomorrow's test, right? So again, diamonds, diamonds, and spades, and so on. That's all this thing does. But what if I wanted to create a subclass of this deck class, right? Now, there could be other kind of reasons for that. My deck class is for every kind of card, right? And it has certain things in here, right? As an example, it has a couple of private member variables or fields, if you will. One of them happens to be an array. Here's the array. And by the way, this syntax, and let me move up the chain in terms of how big this is. It looks pretty small to me right now. So I'm just going to zoom in, and I'm just going to get rid of this. Just zoom in a little bit so you can see this. The syntax here almost looks identical to what you'd see if you were doing JavaScript. Almost. Okay? So it's almost identical. The differences are very little. Again, if you remember from our discussion last time we were here together, the underscore, I'm using the underscore to denote any private member variable. It's just a convention. You don't have to do it. Right? I'm asking you to do it here on in so we can differentiate the difference, or can kind of make the difference between private variables and private fields and public fields and variables. That's all I'm doing. That's why I'm using it for. I'm not doing it for any other reason. It doesn't hold any additional value, just that alone, right? And by the way, you'll see that in many, many, many programs out there, right, where they have this underscore character, right, as a means of us detecting if it's private or not, right? Especially on the JavaScript side, on the website. Okay. So that's all this is doing. And if you notice, this is just a basic class. But let's say, for example, I wanted to create another class. I'm just going to create a dummy class for now. All right? So it doesn't really matter. So I'm going to go, by the way, if you want to follow along with what I'm doing, you can go up on GitHub Let's pull it down for you, right? So if here's GitHub. And if you want to go to my GitHub account, and if you want to search for this class, you can kind of do a COMP123. And if you notice last week, it was COMP123 Lesson 6 Part 3 is what we're going into, right? Which would give you the same kind of stuff that I'm looking at right now with deck, card, face, program, all that stuff, right? So if you want to follow along, you can certainly fork me on GitHub, and that be included in your GitHub account, or download and install this solution for yourself. Remember, everything I do here, I also do on GitHub because I want to make sure you guys have access to all your files. Tomorrow, for the test, you're going to have access to GitHub for my code. You're going to have access to your own assignments, right? Assignment 1, 2, and 3. You'll have access to those things. You'll have access to the book, right? Any of my PowerPoint slides that you have out there. The only thing I'd ask you not to do, and I'm going to monitor you closely about this, is no Googling again, right? So it's the same kind of thing as we did last when we did a test. No Googling, but you have access to all that stuff. So it's not like you're going to be without. The only challenge tomorrow, and again, it is an exam, if I want to talk about this a little bit, is that please be prompt, by the way, it's 8:30 in the morning. I know people wander in it a little bit later. This would be bad for you because you know what? It's going to take your whole time for you to do the exam tomorrow. I'm going to try and start as promptly as possible. I can try and be here a little earlier for those people who want to start earlier. The only challenge with that last time was that people wandered in at like 10 past, 15 past, 20 past, right? And I was still explaining myself over and over again and what this thing was about, right? So I'd like you to be there on time, please. And we're going to end. Even though it's 2 hours, we don't have 2 hours, right? We have an hour and a half approximately. And the reason why is because let's figure 10 minutes in for you guys to settle in for me to explain what the exam is going to be about, right? And then you know what? You can't end at 10:30 because 10:30 people are coming in. So it means 10:20 we'd have to leave, right? Approximately. So that's 10 minutes out of there. So that's 20 minutes gone, right? And then maybe you have to upload your stuff to eCentennial because everything I do is electronic, which means you need another 10 minutes. So probably around, you're going to lose half an hour, which means you only have an hour and a half for tomorrow for your exam, right? It's worth 20% of your mark, right? So this isn't a little exam here. It's a midterm. We've broken out some of the pieces a little bit. You should be trained enough to put these things together. And I'm going to also include some code that I'm going to give you. Yeah.
So is it comprehensive of what you do?
There'll be some pieces that will not be included because I only have an hour and a half, right? So you might be doing something a little bit more advanced than your test, the first test that you did. And again, I'm going to include piece parts that I don't think you can do in an hour, right? Yeah.
What chapters is it?
It's going to chapter the same ones that we've already covered, 9, 10, I think, 11, and 12, if I'm not wrong, something like that. I'll go over it in a second with you, and I'll make sure that those are the ones that are covered. But the same chapters up to inheritance. We're not going to go beyond polymorphism and inheritance until we come back from the exam, which is next week. Next week we'll start some new stuff, right? But again, if you notice, let's go back to what my example is here. So what I want to do is just create, let's do it together. Let's create a subclass of my deck. All right, I'm going to create a smaller deck of cards. As an example, let's say I'm playing a specialized game. Instead of making a whole deck of cards that has 52 cards, my deck of cards is going to have a smaller amount of cards, or maybe have different properties, different additional cards, like jokers. As an example, I have a couple of extra cards. I want to make a subclass of my card class. As an example, how do I do that? Well, first of all, I'm going to go into right-click on my project here in C#. I'm going to add, and I'm going to say new item. Let's do this together. I'm going to go to class, and let's say I'm going to call this, trying to think of what I would call it. Let's call it my deck, right? Because my deck would be the my subclass. Okay. Again, this is just for illustration purposes. It may not make any sense in this particular context. All right. I'm going to click add. So my deck is the new deck, and if you notice, right now, if I wanted to extend, or I wanted to inherit from my deck class, I'm just going to make that a little bigger for you guys to see. Let's zoom in here. Really big, right? So here's my deck class. I want to extend the deck class. How do I do it? Well, I need to use a colon. So if I go colon, and then I say deck, right? If you notice, it's available to me, this deck, because it's already a class I have in my namespace. Here's my namespace, right? So once I've done that, well, I've inherited all the properties and everything else from my deck superclass. So that's the first thing. So when I inherit, I use the colon, right? Now I don't have any interfaces yet, but we're going to build them in, okay? Just for illustration purposes again, for tomorrow, for you guys, right? Now I need to do a constructor. My constructor has the same name as my deck, right? Here's my deck. It's a constructor. And if you notice, I have to follow on because I am inheriting from deck. Let's take a look at deck for a second. Let's bring that up in another window. Here we go. Here's deck. If I notice, the deck constructor is an empty constructor, which is good, right? Because that means I don't have to do much or anything. It doesn't ask for anything right now, which is a very simple constructor. But it does have one method that it fires or it triggers when an object of the deck class is created. This internal private method. Why is it private? Because hey, I've denoted it with this underscore to kind of tell us all that it's private. This private build deck method, right? That's all it does. And so this is triggered when I create an instance of the deck class, right? So going back to my deck, if this is a subclass of that, I can certainly do this, but I still got to call my base class, right? Which is what I'm going to do here. And if you notice, it could be written this way when I extend my base class, and it could also be written, you might see it being written like this. That's fine too. This notation you'll see online as well. So all I'm saying is fire up the base constructor, which is this one, right? So trigger the base constructor when I create an object of my deck subclass. That's all this is. So this is the first thing I'm doing with my deck, right? So let's say I want to create a couple of interfaces, right? And I want to create an interface that is, let's say, called add joker. Or we're going to use the I keyword, the I convention when I create my interface to create a joker, right? So I want to add jokers onto my, my method called add joker. I want to add it into my deck, right? So we're going to do that. We're going to right click here on the project. I'm going to go to add, and then I'm going to go new item, and then I can choose in here an interface. Here's an interface. This is how I would add an interface. So first of all, I'm defining my interface, and we use the I, like an actual capital I, as a convention to denote that it's an interface. I'm just telling you it's an interface by using the I before my thing. So for example, in your assignment, you had I has moons and I have this or whatever. It just means whatever I put in here typically is the method or methods that I want to add into my class, that I want to force my class to have. So maybe I'm going to say I add joker. Right, I'm going to call this I add joker. Guess what's going to be the method? Add joker, right? I'm going to click add for this one, and it's going to define my interface. Now, if you notice, it says it's using the keyword interface. Let me make this a little bigger for you guys. Here we go. Here's my interface. I add joker. And now, in my interface, I'm not going to define the body of my method that I'm adding in, but rather just the method signature. Okay, that's all I'm basically putting in here. So I'm not defining the body. If I try, it won't let me anyway. All right. So let's say I want to create my add joker method. Right. Here's my add joker method. I have to specify a return type because it's my method. I have to specify it out here. And now again, I can specify void, that it doesn't return anything. Right. So and if you notice, I can't put anything in here. This is incorrect. I can't do this. It'll give me an error. What I have to do is just sign it off like this. Right? So all I'm doing here is I'm just telling you that you need an add joker method to your class. But I'm not defining what that method is. That's done in the class that implements the interface. Listen to the words. So when I say implement this interface, all I'm saying is, you know what? You need to add your I add joker interface into the things you're going to implement for your class. Let me save this for a second to show you. So now here's my deck. I am inheriting from deck, and now I want to add, using my comma, and what am I going to add in? I add joker. Right, there it is. So now this comma, right, denotes that I have this is a class, and if you notice I'm hovering over it, it's telling me I have a class. And here, this is my interface. It even says interface in the code hinting. This is how I implement an interface. I add it in here. Now, it's not complete by any means. I have to add in, because I'm trying to implement this iAddJoker interface. Let me just put some comments in here for you guys. Here's some, this is my constructor, right? Right? Just to make it the same as normal, right? And then down here, I want to implement my interface for my iAddJoker. So I'm going to say, you know, override methods, because I got to override, right? Okay, so this is the methods I have to override. And what are they? Well, I have to define it, and I can define it as a public method that I want to do to add the joker, right? So it's going to be, it's going to return void, just like its predecessor, right? And I have to use the override keyword, right? If I want to do this properly, let's try this again. Here's my override keyword, right? And let's see when it gives me an error. Now I'm going to put in add joker, right, as my interface. Okay, and if you notice, I'm going to now override what this is going to do. So I'm going to use a console command, console.writeLine. That's all it's going to do. This simple, silly interface. You know, added joker. Okay, I'm going to save that. So far, I don't have an error. Let's build this thing and see if I get an error, because usually the build will tell you if you're getting an error now. So I go build solution, right? And if you notice, I got a couple of errors right away, right? So here are the couple errors I got. One of them, it says, does not implement interface member, right? This, my deck does not implement my interface member. That's first thing. And the second thing it says is, no suitable method found to override. Okay? So here's for my deck. Those are the two errors that I'm getting. Why? Because when I go over here to add joker, and go back to my add joker interface, this is the method that I've got to override. Now, can I put in any kind of modifier to the interface? Come on, Smarty, you tell me. I got to look at somebody. Can I put a modifier here? Can I put make it public, private, protected? Can I do anything there? What happens when I do? If I go like protected, because some people will try and do this, right? And if I save it, if you notice, my deck right now has an error, showing my two errors right here, right? These are the two errors that I've got, okay? So here's the first one. It says my deck, and it's got this error. It says does not implement the member interface, but well, here it is. And it says, well, this, I don't know what this is, this method, right? Well, what if I take away this public, right? Does it implement it now? Let's see if that is enough, right? How do I implement this interface? It says no suitable method to override. Because when I do that, when I start typing override, okay, if I go back to the beginning, if I start typing override, so override, and then if you notice, here's the ones that I can override right now, equals, get hash, and toString. Why is it showing me these? Because these are the ones that I want to override. And I'm trying to use this override keyword, right? Because I'm thinking in my mind that I got to override the interface. It's wrong. I don't have to override the interface. As soon as I create an interface, I just need to define it. That's what it does. I'm not overriding anything. I'm overriding something, because this is where some people send me email, where if I define an abstract method or a virtual method in my superclass, which I have not. So because I haven't defined those two things and I'm trying to implement an interface, then I don't have to use the override keyword. I just have to do one of these, right? And then if I start typing the for the method to override, I'm talking about, and this I'll call it, instead of override methods, I'll call this interface methods, right? And I'll call this add joker, right? And that's all it is. And let's see now if we're getting an issue. Now, so far it's saying, hey, I've got a problem, but let's build this and see if this solves my problem. Okay, here we go. The modifier protected is not valid for this item because we know, right, if I go back to iAddJoker, that protected, we don't need protected. There cannot be any modifiers here. Let's get rid of this. So that's the other issue for the protected class. Okay, cool. Let us build it again. And you notice I'm building it because that'll give me my errors before I run it. Okay, cool. It says, does not implement interface member for iaddJoker, right? It doesn't do that, and it doesn't do that. It gives me the error right here, right? Here's my interface method. What should I do differently than this? Should this be private? Is that the reason, right? I'm just scoping it out with you here, guys. Do you guys remember inheritance at all in interfaces? Do I have to open up that file again? We have to go through the PowerPoint presentation. I'll do it, right? I don't mind, right? And this is what the problem is, because you guys don't know how to do this stuff, and then when it comes down to it, or you're not reading, and you know how to do this. Okay, so let's take a look. Any other suggestions? Yes?
Try putting an I in front of addJoker.
No, that won't do it. That's the interface. That's up here,
But you're
right? I'm implementing this. I'm inheriting from deck, and I'm implementing this interface. See?
what's the name of the method that you
addJoker, which is right down here. This is my method. Is there something that's missing? Yes? Oh, you're right. I meant to do this. That's an error on my part. All right, so that's very good. Very good that you caught that. And if I go back to my deck now, and I save everything, and I build, maybe then it'll go away. Well, it says cannot implement an interface member because it is not public. Hold on. Does that mean I have to make this public? Guys, I'm doing this on purpose, right? I'm trying to cause these errors so that way you guys can figure out what works and what doesn't. What happens now? It build succeeded. So a couple things. Interfaces. My method for my interface has to be public. All right? That's one thing. Even though here, if you notice in my iaddJoker interface, I'm not defining what the access modifier is, it has to be public because I'm going to override it. I'm going to rewrite it, actually, is what I'm doing. I'm going to implement it. Implementing is different than overriding. Overriding means there's an existing method, and there is no existing method here. All I've done is define my method signature. That's all I'm doing here. But I haven't written the method. The method gets written here in the class that I'm implementing my interface. Clear as mud?
So overriding this work for
I can. If I use the override keyword, I just showed you. Let's try this again. Override. Right? If I use the override keyword and do the same thing, it won't build. Watch. Right? Build. No suitable method found to override. The only way I can override a method is if I have the abstract or virtual keyword. That's the only way I can do that. So I got to take this away. For interfaces, we don't override. For interfaces, what we are actually doing is we're implementing. We're actually writing the method. Okay? So again, let's go back to that assignment. Here is your interface. There's a couple interfaces up here. I'm defining the method, two methods, has moons and has rings. How am I going to write that if I'm making an interface? It's going to look like this, guys, right here. This is what it's going to look like. Oops. It's going to look like this interface right here. I'm just to build this thing so it goes away, the errors go away. It's going to look like this. Exactly like this, except sub out what I said, has moons and has rings and is habitable or whatever it was, and make this is what the interface, this is all the interface, what it's going to look like. And that's it. There's not going to be anything else in the interface. Right? You got it? The interface is just helping us with the shape of our class. It doesn't do anything necessarily. I'll say necessarily because there's more advanced interface types and so on. Right now, the one I want you to get is this one. Get this one first. Then we'll move to the next one. Right? This one, interfaces, all they do is define additional methods for us that we have to include in our class definition. Here, let me show you that. So if I go back to my deck, therefore, and I'm going to just put this stuff in stasis, right? Okay, so let's just try this out. So here's my interface. I'm just taking it out. I'm going to save this, and now look. Let's build it. Right, I'm going to build this solution, and it gives me an error. It says does not implement interface member. Why? Because I told it that I want to implement the iaddJoker interface, but yet I'm not implementing the method that I've told it that I want to implement. That's why it's giving me an error, right? So I got to remove these things. I got to implement this new method. It doesn't do anything, by the way. I'm just demonstrating what it would be like if I needed an interface in a subclass of my deck superclass. Let me save this up, and first of all, I'll build this thing again. Just make sure it's correct. and I'll put this up on, I'll make changes. I'll say, I'll kind of add all this stuff in there. I'll say added my deck subclass, and I add Joker interface. Okay, so I'll do that on the GitHub here. I'll go to home, I'll go to unsync commits, and I'll sync. Now if you go on my GitHub account, right, let's take a look at that really quickly. Here's GitHub. Oh. Go to me, go to my repository here, and here's lesson COMP123 lesson 6 part 3, which is from last week. And if you go in here into the actual lesson, the actual things, I have my I add Joker interface, which is right here, which is really kind of a, I'm being a joker adding the Joker interface because there's nothing really going on, right, with this interface. Let's map this thing out. Let's just to show you the tool, just to be curious. So I'm a little curious, you know what, I want to map out my deck class, and I want to create my UML project. Here's my UML project that I created with it. And here's my class diagram. Let's take a look, right? I have my class diagram, but there's really nothing in this thing. Well, what if can I drag and drop? I want to create my class diagram, right? Well, there's nothing in here for my class diagram. How do I do that, right? Well, the one thing to do is first of all, I have to click on the my deck method. And if you go, and if I say view class diagram, if I click on this, view class diagram, or there's a couple options here, view class diagram and show on code map. Why am I showing you this, by the way? Because it'd be great if you can match up what I have on the assignment with what you have. If what you have on your code map is matched up with my assignment, chances are it's correct, right? So let's try this out. So let's try this. So if I go show on code map, well, that really doesn't do it because this isn't the one I need to use because it doesn't do anything. It just adds a couple of things in here. It shows me a couple of dependencies, but that's all it does. So I'm not going to save this one. Well, let's right click again and go, view class diagram. Maybe that's it. Ah, this looks closer to what I want. Look, here's my interface. And I've got my deck here. That's all I did. I right clicked on the actual class to get this, right? And you know what? Here's class diagram 1. I also want to, there's a couple of buttons up here to see the class diagram. I can display the name and type. And here, if I click this button, I can display the full signature. Okay, let's expand this thing because you can move it around and expand it and make it bigger, right? And if you notice, the methods for my deck class is only 2 methods, add Joker, and these are methods. See how it's split off? Let's put this over here for now, right? And let's add in, I'm just going to drag and drop now that I have this class diagram. I'm going to add in my the deck superclass. Here's my deck superclass. Oh, look, there's a relationship. And you know what? Let's expand this to make it bigger. Okay. And here's my, this is what it would look like right now. I also have my program, which is not related to anything because that's where I run everything. Here it is. I'll make this bigger, right? Hold on. Starting to look more familiar, right? And do I want to drag and drop my interface? Sure, I could. Here's my interface, right? I'll put it up here so we can see what it looks like, right? But it doesn't really say anything except for it's an interface. Does it look familiar? This is what I did when I created your basic assignment. So now look, I got a couple fields here in my deck, a card pointer and a cards array. That's what this is. I also define a few methods in this particular example, right? I have a shuffle method, a top card method, a deck, the deck constructor method, because it's named the same thing as my deck class, build deck, add card, and so on. Make sense? So I did that. The reason why I'm doing this is I'd like you to do it. When you start going to your assignment number 3, when we get a more complicated class for you to build, this is a great way to check your work. If yours looks different than mine, looks different than this, you missed something. Here's another thing you can do. If I right click on this thing, right, I can do a couple things. I can go to view code. So I'm actually clicking on the diagram. I can go to view code and I can go to class details. class details. What if I click class details? What does it give me? My God, it gives me the details of the class. Take a look. I can actually map out all my entire class here, step by step. It tells me my return type. It tells me my modifier. Hey, you know what? Wouldn't it be cool if I can build write additional code by adding stuff in here? Well, you can't, right? If I do an add method or an add property or an add field, it'll do that. It'll add code for me, right? Without me writing a darn thing, right? Let's try this out. Let's kill this, right? I'm going to reduce this down here again. And let's go to my deck. This is the one we're going to play with. I'm going to add a field, right? I'm going to add a property. I can say right here, I can say method, property, field, event. I can add all these kind of things if I want to. A constructor, a destructor, a constant. All these things I can add in here, right? Let's add in let's go to my class details. I'm going to pull this up again from my deck. And in here, instead of adding a method, right, I can add methods. I can also add in a new field. So here's my new field. And my new field is going to be called, I'm going to make a number of jokers. So I'm going to call it, and it's going to be an internal field. So I'll use the underscore. I'm going to go num jokers, right? It's going to be of type int, and it's going to be private. Okay, I've just added that in. Okay, cool. Let's see if the changes went forth, right? I'm going to kind of minimize that and go back. I'm going to go right click here and go to view code. View code. Whoa. Look, private int num jokers. It added it in. It wrote the code for me. So this is a great way of outlining your code. So, hey, let's forego the traditional way of writing and let's write our diagram, make our diagram. By the way, this is done in real life, right? And when we're going to write our diagram and we're going to define all the properties. It's going to outline it for us, and then we're going to mix it up. And we're going to make it so that it looks like we want it to. Like for example, it doesn't add in my comments, although there are plugins for Visual Studio that'll do that too, right? So let's just put something like this, private instance variables. Okay, cool. And that's what this does, right? So again, it doesn't do anything right now. This private int number of jokers doesn't do anything. And you know what? What if I want to take in an integer here, my constructor? Let's change something here, int, right? And I'll say num jokers, right, to add how many jokers I'm going to add. And in my base class, I'm not changing anything in my base class, but I'm going to launch this method called this add joker method here, right? And I'm going to pass it, when it does something, it's going to return void. But this add joker method, I want it to take num jokers, right? Well, if for me to change it here, I can't do it here because I'm implementing the interface. And my interface, my method signature doesn't include any kind of parameter. That means that I've got to go back to the add joker interface right here, and I'm going to add in a parameter, so int, and I'm going to take in num joker. Maybe num jokers, let's just say. So it's going to do that, but in order for me to implement it properly, now I go back to my deck. It requires that I have num jokers, so I'm going to say int num jokers, right? And if you notice, I'm going to pass in, right, the number of jokers, but I want to also record it. I just don't want to pass it in. I want to record it, so let's just do a little bit of finagling here. I'll say this int num jokers is equal to num jokers, the one that gets passed into this local variable that gets passed into my class. And I want to send in my private member variable. I don't know what happened there. My private member variable that is, we're on emergency power. My private member variable that is num jokers. I know. See, I'll turn my laptop around. But anyways, the idea here is the stuff I've been talking about when I implement my classes and everything else is what I want to do. Again, the keywords that I have to use when I use the words interface, and I say implement interface, right? Or if I say extends the subclass, when I say the word is extends, I want you in your brains to translate that to say extends means I got to use the colon, Tom, right? And implements means I need to use the comma after the thing that I want to the class. But can you implement an interface without inheriting from a class? Yeah? Yes, you can. Instead of the colon having the class first and then the interfaces, you can do just the interface. You can just implement an interface. You don't have to extend a class, like inherit from a class and extend. Huh?
So you just put interface.
Comma, no, not comma interface. You just can put colon interface, whatever the interface. The colon is, it tells us from an inheritance perspective what I'm implementing. Am I inheriting from something, or am I implementing an interface? What am I doing after the colon? You can put either way, class or interface by itself. If you want to put multiple things, you can put one class and a number of interfaces. But I believe the syntax is you should put your class first, best practices, and then all the interfaces after, comma, 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 comma. Okay, that's the way it goes. So just, kind of talking about basic syntax here. Hopefully the power will turn on and we'll be able to do more with this class. It wasn't me, right? Okay, so you guys don't have power in this room. We can also check, we see if we have power in other rooms. I'm going to obviously take a short break while we do that, because it doesn't make any sense for me to continue if you guys can't see what the hell I'm doing. And I'll take some questions.